This is the Air Force Station, Georges Bank, a stationary radar platform located 160 miles east-southeast of Boston, Massachusetts. Because of its resemblance to the offshore oil rigs in the Gulf of Mexico, it is called a Texas tower. This film is a photographic report of the first of a chain of these towers to be placed along the Atlantic coast to form a radar guard against surprise attack from the sea and to act as control centers for defending fighter aircraft. Here is a scale model of the final design. The triangular shape provides adequate space for personnel and equipment, as well as ample deck area for helicopter landings. And the three legs, firmly embedded in the ocean floor, provide a stable platform support with a minimum resistance to wave action. The deck house at the rear of the platform contains electronic equipment. On the deck house are three of the now famous Arctic radomes, which protect the radar antennas from the effects of the North Atlantic weather. The main deck of the platform is 83 feet above mean low water. The radar antennas are raised high above the deck. The helicopter landing area and two boom derricks are seen forward of the deck house. On the shore side of the platform are three microwave antenna dishes, and below is a rotary scaffold for underside maintenance and repair. Frequent bad weather, strong tidal currents, and the remote location made on-site construction impracticable. The platform was to be built ashore and floated to the site. Two problems were involved. Could a structure of this shape and weight be towed over 100 miles to sea, and once there, could it be raised into its position 83 feet above the sea? Model basin tests indicated towing characteristics would be good, even with the three permanent legs and the 12 temporary legs extending 150 feet above the platform deck. These temporary legs would be attached to the platform by 6 brackets placed at the corners of the platform. They would be detached after the platform was lifted into place and rigidly connected to the permanent legs. After the platform reached the site, all 12 temporary legs would be dropped simultaneously to the ocean floor. The problem of raising the platform from the water to 83 feet in the air would be solved by use of air jacks. Mounted around the legs, the jacks would climb upward, carrying the platform with them. Jacking is stopped after the platform breaks water and the permanent legs are lowered. Jacking action is then resumed. Actual construction began in January of 1955 at Quincy, Massachusetts. In order to be towed to sea, the platform, like a ship, had to be watertight. So the beginning of construction was referred to as the keel laying. The main structural frame consists of 3 box girders, visible here as the sides of the platform. These girders are 190 feet long, 20 feet wide, and 20 feet deep, and were fabricated here on the shipways. Inside these girders are 2 decks. On the upper deck, where the man is walking, the power plant and berthing spaces for officers and crew will be placed. Below, on the lower deck, will be the heavier loads, such as boilers, fuel and water tanks, and storage spaces. The mess halls, galley, and maintenance shops will be placed in the triangular area between the girders. Here, a prefabricated section is lowered into the hull of the platform to be welded into place as a part of a wall. It is interesting to note that there were no unusually large subassemblies, as most of the fabrication was done on the platform during building. By May, the platform was nearing completion and was ready for launching. The interior compartments were finished and the hull made watertight. Only 4 of the 6 temporary leg brackets were attached at this time due to clearance problems in passing through the Fall River Bridge. The platform was now ready for launching. Due to its triangular shape and the off-center angle at which it will enter the water, the launching would be slow and controlled. Not as spectacular, perhaps, as a ship rushing down the ways, but just as effective. These piles of heavy anchor chain will be used as deadweight drags to slow the platform, and tractors will control its movement by pushing or pulling as necessary. All was in readiness. The crowd gathered for the launching. The platform was christened. The final restraining plate cut with a torch, and the Texas Tower was on its way to becoming the first Air Force station to be christened and launched. The ways were well lubricated, as you can see from the grease piling up in front of the skid, but the drag chains were effective and slowed the movement of the tower, while the tractors maintained control. The cables were paid out slowly. The platform neared the water, but then slipped sideways, colliding with a concrete footing. Under the platform was a jumble of wreckage, the result of a collapsed way, a mass of splintered timbers. The workmen attacked the debris immediately, but to complete the job, the tower would have to be raised and supported during clearing operations. Air jacks were brought in from the fitting dock for installation, and a huge floating crane was moved to the shipyard to lift the heavy temporary legs aboard. It also lifted this mobile crane under the deck to assist in setting the legs. The mechanical gripper rings were placed over each leg well. Then, 2 air jacks were placed on each of them, and the lifting bars connected. These bars secured the jacks to the platform. Sections of the temporary legs were picked up from barges alongside the platform and lowered into place through each pair of jacks. The platform was now ready for lifting. After connection to air compressors, the controls on each jack were operated manually, and the platform was raised high enough to remove the last of the wreckage. Old pilings were sawed off, crushed lumber hauled out, and cast aside. After the area beneath was completely cleared, the platform was lowered. And the next high tide, with the help of tugs, it was pulled clear and floated. The launching was complete. During the night, the platform was tied under the huge hammerhead crane at the fitting docks in Quincy. Here the permanent legs were added. The lower section is a steel cylinder 15 feet in diameter and 62 feet long. Upon reaching the site, these will be sunk 45 feet into the ocean bottom to form a stable base for the platform. A lower section was placed in the well on each corner of the platform and fastened into place by steel pins. New sections of the permanent legs were brought aboard. These were 10 feet in diameter and were lowered about 1/2 their length into the center of the larger sections. The 2 1/2 foot area between the two will be filled with concrete for additional strength and permanence. During this time, additional 65-foot sections were being added to the temporary legs to bring them near their required height. The sections were checked for alignment, and the seams welded both inside and out. After the alignment, brackets were cut off and welds were ground smooth to allow the jacks to pass freely over the joint. Each permanent leg was encircled by a steel bridge which spanned 2 jacking columns. These were firmly attached to the deck on each side of the leg. A jack was then placed on each column inside the bridge. Thus, 2 jacks 6 feet in diameter could be used on the permanent legs. This bridge was fastened to the leg by steel pins, so by jacking the bridge up or down on the columns, the platform could be raised or lowered. The hammerhead crane then added more permanent leg sections. Due to crane height limitations, the final sections were to be added at the East Boston shipyard. Except for the final height, the basic leg installation was now complete. 15-foot diameter leg sections, jacking columns, jacking bridge, and main leg. The darker sections of the legs will be in the splash zone on a completed tower and are Monel clad to resist corrosion. The platform was now ready to move to the East Boston shipyard for final fitting out. On an early morning in mid-June, the tower was passing through the Fore River drawbridge on the way to East Boston. At this hour, local bridge traffic was light. Since the tide was slack, there was no current to fight while maneuvering the tower through the span. It was a tight squeeze. Clearance was less than 2.5 feet on each side of the platform. Ample reason for leaving off the remaining temporary brackets until reaching East Boston. Overhead clearance was also critical. If the legs had struck the bridge span, a great amount of damage would have been done to both. But with the tugs pulling and maneuvering, the legs cleared the span, and the tower emerged unscathed. With a blast of the whistle to signal the bridge operator to close the span, the tower proceeded down the river. By noon, it was approaching the East Boston shipyard. The tugs were pushing now in order to jock it into its prepared berthing space. The lines were thrown over, and the Texas Tower was secured for final shoreside outfitting. The last 2 temporary brackets have been added, and the jacking assembly and temporary legs have been installed. The massive equipment that will be needed during lifting at sea is in place on the deck house. On the main deck is the jack control panel. From here, all the jacks can be operated singly or in unison. With the 12 temporary legs installed, the jacks were put into operation. The weight of the platform forced the legs deep into the mud, at the same time raising the platform. This lifted the deck cranes up to a height where they could add more sections to the tops of the legs. As additional sections were brought aboard and welded into place, the tower was raised further, and the final sections added to the temporary legs, bringing them to their full 195-foot height. Underside details were also added at this time. These permanent well extensions add an additional 10 feet of bracing to the underside of the platform. Preliminary concreting operations were performed here at East Boston. The annular space between the inner leg and the outer caisson was filled with coarse aggregate and concreted by pressure grouting. Due to weight limitations during towing, the cutting edges of the main caisson were filled only to a depth of 14 feet. To make up for time lost during the launching at Quincy, the top section of each permanent leg was not installed, but brought aboard and stowed for installation at sea during jacking operations. The platform has now been lowered and is ready to be towed to sea. The equipment on the deck house was checked for stowage and everything secured for the voyage. Last-minute adjustments were made to the platform, and when the orders were given, the Air Force Station Georges Bank was off on its first and last ocean voyage. Underway, the platform was towed by 2 tugs, each with a separate tow line to the platform. In the harbor, where maneuvering was necessary, there were also tugs pushing, but these dropped back when open water was reached. The tower soon passed the limits of Boston Harbor and slowly proceeded to sea. The average speed for the trip was 3 knots, faster than expected as the sea was smooth. The tower arrived at the selected site at night. With the help of the Bear, a ship from the Woods Hole Oceanographic Institute, it was accurately positioned and anchored for several hours to await a favorable tidal current. Then the 12 temporary legs were dropped in unison and jacking was started. By morning, the tower was jacked up enough so that it had stopped bouncing with the waves and was starting to clear the water. As soon as it reached this stage, the permanent legs were gradually lowered. This took 1,800 tons of weight off the platform and afforded 6 more jacks for lifting. Aboard the tower, all were busy. The core drill took samples of the bottom to confirm that the ocean floor was the same as the original borings, a dense gray sand. Jacking operations were progressing steadily as the big jacks climbed slowly up the legs. The tower was well clear of the water, and the work barge has been towed out and moored alongside. The barge carried additional construction materials and supplies to the site. The top section of each permanent leg was welded on during the jacking operations, bringing the legs to their full length. When the tower was jacked high enough for the deck cranes to have access to the top of the permanent legs, a 6-inch diameter dredge pump was hoisted up to be lowered through the leg into the caisson. To sink the caisson to its required depth, high-pressure water jets washed the sand from under the edges. The weight of the tower then forced the legs into the resulting hole. The purpose of the dredge pump was to suck the water-sand mixture out of the leg and to pump it into the sea. Water for the jets was pumped aboard through these temporary water pipes by large centrifugal pumps on the deck edge. By this time, the tower was almost at its full height. Work was being speeded, for hurricane conditions were forecast, and the tower needed the permanent legs in place and secured for final strength. This tanker brought extra fresh water for concreting operations and crew use. It was pumped aboard to tanks in the platform. The El Sal, an ocean-going tug, was used to ferry men and supplies to the tower from Boston 160 miles away. The dredge pump broke down while working on the first caisson. The assembly was dismantled and hoisted out of the leg. Instead of waiting for repairs, a clamshell and deck crane were pressed into service and finished sinking the 3 caissons. The storm was getting nearer. Personnel not vitally needed aboard the tower were evacuated using the basket, the only means of getting on or off the tower. The full force of the storm missed the tower, however, and work soon got back to normal. But the men were not breathing easily as yet, for the hurricane season was far from over. The cement grout for concreting was mixed on deck. Cement used for fill purposes only was mixed with salt water. If it was classified structural, fresh water was used. The tower is at its full height. The rotary scaffold has been installed. The bridge and jacking columns have been removed, the caissons filled with aggregate, and the permanent legs welded into place. Then the pump forced the grouts mixed to the consistency of waffle batter into the bottom of the caissons, filling the voids in the aggregate from the bottom up. When the jacking columns were cut off, they were lowered into the main leg and used as forms. The space between the column and the leg was filled with a structural concrete to give additional strength to the leg. The pipes embedded in the concrete are to bring water aboard for use in the finished tower. The temporary legs were no longer needed, so the jacks were lifted off and one by one the brackets cut loose. Then the entire assembly was pulled out of position by the tug El Sal and towed back to Boston for storage and use on future towers. Now that the temporary legs have been removed, the side portions of the deck house can be built. Prefabricated plates were extended over the sides at the rear of the platform and welded into place. Bulkheads were erected, and the basic hull of the platform was now complete. The legs are in place and welded solidly. The tower has become an island. The radio towers, the framework for the radomes, and 2 of the 3 heavy steel protective fenders are now installed. On November 17th, when the seas were getting rough, the tug El Sal and the smaller M. Moran arrived at the tower with an inspection party for what was to have been a 3-hour visit. As the inspection party was being hauled aboard the tower in the basket, the weather became worse. The seas had become so rough that the skipper of the M. Moran had to head for port. Finally, it got so bad that even the El Sal had to head for calmer waters, leaving the inspection party stranded on the new and untried Texas tower in the midst of a surprise northeaster. This storm developed suddenly and had winds of hurricane force, with waves over 60 feet in height. This would be a test of the strength of this new tower. During the night, the 2 fenders broke loose from their moorings, where they had been hoisted supposedly beyond the reach of the waves, and 80 tons of metal crashed against the legs of the tower. The ladder of the rotary scaffold was caught in a lowered position and was ripped loose. But the tower itself had withstood the worst North Atlantic storm in years, a storm in which 2 ships had disappeared without trace, yet it had sustained only minor damage. Here is the Air Force Station Georges Bank as she stands today. Tall and proud, she is a monument to the engineering genius and the inter-service cooperation so necessary for our national defense. A lonely sentinel guarding against a sneak attack.